Hey guys, I'm coming right at you with a little bit of a rundown on how to do some of this crazy stoichiometry stuff. I know that's a big word and it might sound intimidating, but you guys can all do this. There's a step-by-step way to do this, which I know you can all do. So I'm going to run through an example real quick and also teach you how to do it as we go through it. So let's get right to it. Okay, here we go. I've got a problem that I wrote out for you right here. And if you check this out, it says calcium hydroxide and phosphoric acid react. Oh my gosh, you might be thinking, what the heck? Okay, so you can do this step by step. You know what these chemicals are. You should know how to write them by now. If you don't know how to write them, go back and look at some previous videos on how to do that. And then we're going to set up an equation. So we talked about how to do that. And there's a natural flow about how this goes. So let's just go ahead and do that part first. Okay, let's take a look. So it says calcium hydroxide and phosphoric acid react. Okay, so calcium hydroxide. You know, first we're just going to write out these two. So, let's go ahead and do that. So calcium's right here. I got Ca. And I noticed that calcium is a positive over here. It's one of my cations. Hydroxide is one of those ones that's going to be on the back side of your paper here. It's going to be one of your polyatomic ions. So you want to always remember that hydroxide. You'll have trouble trying to look it up on the other side. So if you have trouble, always check back here. Most of these end in ate or ite. But this particular one doesn't, and so it's kind of one that's good to have in your mind that you know it's back here. So look at that. That's OH, and it is, so I'm going to write that on there, OH. And now I see that that is a -1. So just the negative little thing up there means -1. And I see that calcium, you should have written in here, you should know that all of these down here are +2. So calcium being +2. So if I have this +2 and this one -1, I know those are the charges. I'm going to go ahead and cross them. I don't have to write my ones. So there's that one. I'm going to go ahead and erase these things up here because I don't need them. Just wrote them up there for reference. Okay, so now react with means that I'm going to go plus, and then the next one. Phosphoric acid. Oh my gosh, you might be thinking, I don't know how to do that. Well, you didn't teach us how to do acids. Yeah, I didn't. Not yet. But what I did do is this. Check it out. All of the acids I listed for you right here that we're going to use. So there you go. That makes it kind of easy. So you might not have noticed this little section on the back side here. It says phosphoric acid, H3PO4. H3PO4. So not a lot of hard guessing on that one or figuring out because list them. So if it says acid, you should be able to look it up right there. And all these things, of course, can be looked up pretty easily anyhow to double check your work. But you do need to know how to make sure that you write them out correctly like that. And that's super, super important. All right, so now we draw the arrow because what's going to happen is we're going to have a react and then we're going to have reactants. So this is where it gets a little bit more complicated, but you can do this, okay? And so the trick to this is to look at and see what type of reaction this is, all right? Now, you'll notice that what we've got here is a positive negative and a positive negative, positive negative, positive negative. You got two double sets of positive negatives here. And so this is a double replacement, double displacement. Those are the same thing. And so what I'm going to do is I'm going to, whenever you have two sets of ionically bonded things, positive, negative, you're going to switch the positives here. And so here we go. Yeah, so here's the deal. This is what we call a double displacement reaction. So what you're going to do is switch your positive. So if this is my positive, I know that's my positive and that was my negative half, right? Over here, the hydrogen's my positive and the PO4 is my negative half, okay? So I'm going to go ahead and flip those around. Now, so I take this calcium then, and that's going to go with the PO4. So I have my calcium with my PO4, right? And so PO4 is phosphate, and you gotta look up your charges again over here. So phosphate is going to be -3, and this is really, really important. Don't forget these steps. So we already knew that our calcium was +2. My phosphate is -3. See, now if I just write that out, that doesn't cancel, so that's not the way it goes. I need to actually put a 3 here and a 2 there. Cross those like we know how to do, and now that is set up correctly because I have 3 +2s and 2 -3s, you see. Okay, so then, and I can erase those charges up there. I just wrote those for reference. And then plus, look, I got my H with my OH. Now I can just write that, H and then OH. But hopefully you guys are recognizing HOH. That's H2O. There's 2 H's and 1 O. So I'm going to go ahead and erase that then. I just wrote that because if you ever end up with that guy right there, just like let that mark in your mind. Oh, wait a minute. That was just H2O. So here we go. I got my H2O right there. Now I have written out my complete reaction and I am ready to balance it. Okay, now you remember with balancing, you're just counting things up. You do oxygen and hydrogen last, or oxygen last, hydrogen you could try to do second to last. But let's go ahead and do it this way. So I got calcium, I got 3, and I got 1. Okay, so I got 3 calcium, so I'm going to put a 3 here. Okay. I'm going to look at my PO4s. My PO4, I've got just 1 of those PO4s here, and then I've got 2 of those PO4s here. You can always treat those polyatomics as a packet if they appear on either side. So I'm going to go ahead and put that 2 right there. And there we go. So because I had 2 of those PO4s right there. Now let's look at oxygen. So if I look at oxygen, I've got 2 times 3, so that's 6 oxygens, plus another 4 times 2, so 6 plus 8, so that should be 14, right? And so let's go ahead then and look over here at my oxygens. So here I've got 8 oxygens, or no, wait, that was I was going to do hydrogens. I'm sorry. So I got 6 hydrogens. I'm going to do oxygen last. Let's go ahead and do that. So I got 6 hydrogens and 6 hydrogens. So that's 12 hydrogens. Okay, so over here I've just got 2. So if I put a 6 here, let's see what happens to my oxygens now. So I counted my oxygens a little bit before. I've got 6 here because I've got 2 goes to that times 3. And I've got 8 here, so that's my 14. So let's look over here. I've got 8 plus 6. That's also 14. So the oxygens worked themselves out. All right, so there we go. So step 1, write out your reactants. Step 2, form your new products over there. Step 3 is balance the equation. Let's go ahead with the final step, which is to do our mole conversion. So here I go. I got 15 moles of calcium hydroxide. So I'll go ahead and write that there. And what I want to do is convert that to moles of water. So this is what I want to get. My end right here is moles of water. So I'm starting with moles of calcium hydroxide, and I'm going to end up with moles of water. So if I go to my very important chart, I can see that I can go moles of one thing to moles of another thing by using the ratio. Now, what is the ratio in this situation? We talked about what is the ratio within a formula like here, a chemical formula. But what about within this? So if I'm going to go over here to moles of water, okay, I'm going to bring this down diagonally. I'm going to bring down my unit here diagonally. So I got moles of calcium hydroxide because I need to cancel that. Okay, so, but right here I need to use my ratio. Anytime you go from moles of one thing to moles of another thing, you need to use your ratio. Now, what is the ratio of CaOH2 to H2O? Let's take a look. I've got 3 to 6, which is really 1 to 2. So what you're doing is you're using the balanced equation to figure out the mole ratio, okay? So I could just put 3 and 6 in there. It wouldn't matter. I'm still going to get the right answer. Or you could reduce it. But in this case, it doesn't even matter. What I would do is I would just always just write in what are your coefficients when you balance? And that's why balancing is so important. Gives you the right answer here. Now what we're going to do is we're going to multiply the tops and divide the bottoms. So I'm going to go 15 times 6 divided by 3, and my answer is 30. So you see that, 15 times 6 divided by 3. Press multiply on the top and divide on the bottom, and you get 30 moles of water is my answer right there. So good job on that. So just as a little bit of a recap, okay, so let's go ahead and write this out. So step 1 is to write out reactants. Write out reactant, and remember reactant are the things on the left-hand side here of the chemical formula. Okay, so write out reactant formulas. So that's that right there. Step 2, what we did is solve for products. Okay, and that's the products right here. That's what we did right there. That was the solve for the products. And remember, we rearranged those reactants to match up to the products that were there. Step 3, set up dimensional analysis. Okay, and you got your start end because we got a number for our start. Okay, our start was 15 moles of calcium hydroxide, and then we put that, set up our dimensional using the very important chart. Remember, we use that. And then step 4 is going to be to solve by dividing top, or multiplying top and dividing bottom. There you go. So right there is going to be solved by multiplying the top and dividing the bottom. All right, so there you go. That is just a quick example of that. I can do more examples as we go along, but just wanted to give you some step-by-step on how to do these.